So we will move on to our next speaker, Michael Johansen, who will talk about STMD dust mitigation strategies.
Hey, good morning, everyone. The name is Michael Johansen. I am the Technical Integration Manager in STMD, responsible for the agency dust mitigation strategy. So I work across the mission directorates, be it SMD or HEO or STMD, to make sure that we lay out an appropriate strategy from a technology standpoint and also an operations and architecture standpoint to solve the dust problem. Next slide, please. All right, so Joel started with a quote, so I think I can too. So probably one of the most difficult jobs of all the closeouts is trying to dust the suits. The real-time transcripts will show just how much time and effort was spent in dusting. That's Gene Cernan, Apollo 17 commander. This is important because this is the last time that humans were on the lunar surface. So if we go down to EVA3 closeout audio transcripts, it says, "Boy, I tell you, I ain't going to do much dusting after I leave here ever." And 3 minutes later, again, "Boy, you got dirty today. I think we're just going to have to live with it." Well, unfortunately, with the architecture that we're moving to in the future, with a more sustainable architecture, with hardware and folks that are going to live on the surface for a lot longer of a period of time, we can't just live with it. And so my role in the agency, along with a number of technology developers and other stakeholders, is to lay out a dust mitigation strategy that is both feasible for short-term missions while also looking ahead to the future as we move to more long-term lunar exploration. Next slide, please. All right, so Jorge talked on this briefly, but to help us coordinate a few technology areas a little better, NASA has formed the Lunar Surface Innovation Initiative. One of the focus areas being on lunar dust mitigation. We use this to, it's not a program, it is really an initiative. It's to enable us to work better with HEO and SMD and with folks on the outside of NASA to answer the agency need for lunar dust mitigation. Next slide, please. And again, Jorge mentioned the LSIC. So I view the LSIC, the Lunar Surface Innovation Consortium, as our way to coordinate with industry, government, academia, nonprofits, and also with NASA to come together for a joint solution on how we handle the lunar dust problem. So Jorge and others already discussed this, so we can move on to the next slide, please. So the things that we need to protect tend to fall into one of these areas, be it optical systems when we're looking at viewports and camera lenses or solar panels or thermal surfaces, of course, things like thermal radiators or fabrics for spacesuit fabrics or softwall habitats or mechanism covers. From a mechanism standpoint, we have linear actuators and rotary joints and a variety of things there that you can imagine. Seals and soft goods, we have spacesuit interfaces and hatches and connectors, hoses, a wide variety of things. Of course, when you bring dust into a habitat, you've got to filter that dust out of the atmosphere that the astronauts will breathe. So we need atmosphere revitalization, but also this covers ISRU process filtration as well. And then one of the things that I also include in the capabilities that the agency and really the world needs in terms of dust mitigation is in lunar surface modification. So this includes things like whether it's lunar landing pads or dust-free zones in general or workspaces. So all of those capabilities fall within the focus area of dust mitigation technology development. Next slide, please. And I think that time can't be right. I think I was supposed to have 10 minutes. I don't think I've spoken for 10 minutes.
Yeah, you have time.
Okay, good. So one of the things that I wanted to discuss here is one of the programs within NASA, the Game-Changing Development Program within STMD, has a current project with a number of investments. So we are looking at developing the electrodynamic dust shield that is an active dust mitigation technology to be demonstrated on a CLIPS payload or this patch plate materials compatibility assessment. So in this case, we're looking at how materials interact with the dust, what kind of coatings we can put on these materials to lower dust adhesion. Or on the technology development side of things, we have dust tolerant mechanisms where we're looking at how we are how we manage seals and things and mechanisms or mechanism covers. We have another effort that's looking at a wide variety of active and passive materials and mitigation strategies called low dust. And then two of the other things that we're developing currently that you may see more of in the future is the Dust Mitigation Best Practices Guide and the Dusty Environments Classifications. So one is a high-level, more policy-like document that these Dusty Environments Classifications, which will enable systems engineers to write better requirements and folks to be able to do integration better. From an architecture standpoint, you'll be able to match up architecture elements better. And then, of course, on the technology developer front, what we can do is we can set boundaries for how good is good enough in dust clearing. We'll never get all of the particles off of surfaces, but we have to find some limit to what's good enough, and these classifications will help with that. And then secondly, a Dust Mitigation Best Practices Guide. Now, this is that how-to guide for dust mitigation to be used by a variety of stakeholders. Here's what we know. This is what we would do. Next slide, please. All right, so we also have made some investments on the SBIR front in active and passive surfaces. We've made some investments in bendable electrodynamic dust shields, what we're calling an integrated approach to active and passive mitigation, and also some protection on solar arrays. On the mechanism side of things, we're looking more carefully at how we do joints and a self-cleaning dust-proof fluid and gas connector and high-powered near-field wireless transfer and for dust-intensive applications, so wireless power. So you don't have to make those connections. And then on the filtration side of things, we're looking at lunar dust filter for spacecraft atmospheres. Applied Particle Technologies has this is more of a measurement type approach for managing lunar dust, and then a submicron particulate separator. So those are the investments we made this year in SBIR. Next slide, please. So one of these calls that are out right now under review is the Early Stage Innovations call. Topic 2 for early stage innovations involves modeling of lunar dust behavior and mitigation techniques, looking specifically at modeling particle adhesion and cohesion, particle transport, lunar dust particle characteristics overall, and then evaluation of mitigation techniques. So not much to say here right now. The proposals are under review. So there's not much we can share at this point, but selection notification is scheduled for October of 2020 with an award date in mid-January of 2021. So this is the modeling piece of how we bring universities into the picture for the agency dust mitigation strategy. Next slide, please. All right, one final thing, one final investment that I'll mention here is NASA's Big Ideas Challenge. So this is something that's open now. Notices of intent are due in September, I believe, mid-September. The Big Idea Challenge stands for Breakthrough, Innovative, and Game-Changing Ideas. It's open to all U.S. universities who are affiliated with their state space grant consortium, and we're looking at a wide variety of technologies in this case. So landing dust mitigation, spacesuit dust tolerance, exterior dust cleanup, and cabin cleanup. That solicitation was released July 22nd of 2020. And if you click on that link from these slides that were given to the moderators here, you should be able to find out more information on that. So this is the other part of how we're bringing universities into the fold for technology development for the agency dust mitigation strategy. It's important to point out that a year and a half ago, these investments did not exist. The agency has really pushed forward with the agency dust mitigation strategy, realizing that it's one of the principal issues that needs to be solved. And Kristen Jano, who I believe is up next, will talk more about specifics to a program and why dust mitigation is so important. But one final thought, next slide, please, is we have to incorporate all of our lessons learned from surface operations and habitats, descent and ascent and orbital areas of operation into an integrated dust mitigation strategy. In order to have an end-to-end best-case approach to how we handle the dust, we have to consider how much dust we have in the spacesuits and then how much that brings back to habitats or descent and ascent elements, and then ultimately back to orbital assets, be it Orion or any kind of private entity as well. So this is one area that there's not too much I can share about today, but we are looking at an integrated approach, bringing all the pieces together across all these different operational areas to do much better, I would say, this time around with the lunar dust problem. And with that, that's my last slide. Thank you.
Thanks, Michael.